A timber-framed chimney chase is one of the most misunderstood structures in residential construction. From the outside, it often appears to be a simple vinyl-sided box rising above the roofline. But inside that box is a complex combination of structural framing, fire protection components, moisture control layers, and mechanical clearances. The challenge for technicians is that the building codes do not provide a step-by-step explanation of how a chimney chase should be constructed. The IRC describes what clearances must be maintained, how fire stopping must function, and how siding and sheathing should perform, but it never presents a unified picture that ties all of these components together. As a result, builders frequently rely on guesswork or tradition. This has led to widespread problems in the field, especially with vinyl-sided chases. Vinyl siding presents a clean and inexpensive exterior finish, but it is only a cladding. It does not keep water out, and it offers no structural rigidity. Beneath the siding must be a properly framed, properly sheathed, and properly protected structure. The heart of this work begins with the required clearance to combustibles. Factory-built chimneys are always tested and listed with a specific clearance requirement, most often 2 inches in every direction. This clearance must be preserved from the firebox connection to the top termination. The wood framing of the chase must not touch the chimney. The sheathing must not encroach upon it, and insulation must never be stuffed into that space. Maintaining the chimney's clearance envelope is not merely a recommendation, it is the foundation of fire safety inside the chase. Within the chase cavity, fire stops must be installed wherever the code requires concealed vertical spaces to be interrupted. These locations include each story level and the attic floor. Modern chimney systems are supplied with fire stop radiation shields, which must be installed properly and integrated with the surrounding framing. One of the most common defects found in older chases is the complete absence of fire stops, which effectively turns the chase into an open chimney that can accelerate the spread of fire within the home. The wall framing of a chimney chase should be treated exactly like exterior wall construction. Although the IRC never provides a specific chase diagram, the normal principles of wall framing apply. Studs must be straight and properly spaced. A double top plate must be used to tie the walls together and resist outward thrust. Corners must be framed in a way that allows full sheathing attachment. A chimney chase should never be framed as a decorative enclosure. Rather, it must behave as a structural wall system capable of resisting significant wind loads. Tall, slender chases in particular must be constructed with the same attention to strength and stability as any other exterior vertical structure. The exterior sheathing is what transforms the chase from a flimsy skeleton into a rigid, shear-resisting element. Materials such as plywood or OSB, when nailed according to proper fastening schedules, lock the studs together and prevent lateral racking. The type of sheathing and the spacing of the nails determine the level of lateral resistance the chase will have. This is critical because a chimney chase is constantly exposed to wind pressure, roof-generated snow loads, thermal movement, and in some cases, the suction forces created by storms. Without proper sheathing, the chase can twist, lean, or collapse long before the chimney itself ever develops a problem. Once the sheathing is in place, the structure must be protected with a weather-resistive barrier, often simply referred to as a house wrap. Vinyl siding is not waterproof, and water readily passes behind it during wind-driven rain. The WRB must be installed with proper laps so that water always drains downward. At the roof-to-chase intersection, correctly installed flashing is essential. Many of the worst chase failures occur not because of the chimney, but because flashing was never installed correctly. Missing or improperly integrated flashing allows water to soak the sheathing, saturate the framing, and eventually cause structural decay. A chase can appear perfectly fine from the outside while the interior framing is rotting away behind the siding. The absence of prescriptive code illustrations leaves many construction professionals confused about how these details should be assembled. The code provides fragments of the picture, clearances in Chapter 10, wall framing rules in Chapter 6, WRB guidance in Chapter 7, fire stopping requirements in Chapter 3, but nowhere does the IRC put these pieces together to form a coherent construction method. This lack of integration is why chimney chases are often built incorrectly, why vinyl-sided chases are prone to water intrusion, and why so many chases fail long before the chimney system reaches the end of its service life. In truth, a properly constructed timber chimney chase is a combination of structural wall engineering, fire protection strategy, and moisture management design. It must support lateral loads, protect combustible materials from high temperatures, and prevent water from entering the structure. When framed and detailed correctly, a chimney chase can last for decades with minimal maintenance. When constructed poorly, it can become one of the first elements of the home to fail. Brick veneer chimney chases present an entirely different set of challenges, and in many ways, they fail more dramatically and more frequently than their vinyl-sided counterparts. At first glance, a brick veneered chimney looks solid, substantial, and durable. Brick has a way of reassuring the homeowner that the system is strong and permanent. Unfortunately, the opposite is often true. A brick veneer chimney chase, when constructed over a timber frame, becomes one of the most failure-prone assemblies in residential construction, and the problems are rooted not only in poor workmanship, but in the inherent design limitations of the system itself. The first major issue is weight. Brick veneer is heavy, astonishingly heavy, and yet builders frequently ignore this reality. In countless homes, the entire weight of the brick has been inadvertently loaded onto roof rafters rather than carried down to a properly engineered footing. Roof framing is never meant to carry the dead load of multiple courses of brick, and when this mistake occurs, the chimney can begin to distort the roof structure, sag the rafters, or shift the entire chase laterally. A brick veneered chimney must have a continuous, engineered load path to the ground, but many builders have never been taught how to create that path. As a result, the brick chase becomes structurally unstable from the moment it is built. The second major failure mechanism is water. Brick is a porous material. It absorbs and releases moisture constantly. Under wind load, a tall, slender chimney behaves like a bending column. When the wind pushes against the brick veneer, the brick experiences alternating compression and tension. Over time, this repeated bending action cracks mortar joints, loosens brick ties, and opens small, unseen pathways for water to penetrate the veneer. Once water finds its way behind the brick, it enters the timber frame chase. If the framing cannot dry, the structure begins to rot from the inside out. These failures often take years to become visible, and by the time a technician encounters the problem, the damage is widespread. The problem is made worse because builders routinely fail to provide proper weep holes at the base of the veneer. The purpose of a weep system is to allow absorbed moisture to drain out of the cavity behind the brick. Without weeps, the cavity becomes a water trap. The WRB behind the brick is typically perforated by fasteners, staples, nail holes, and tears, which means that trapped moisture eventually finds its way into the wooden chase structure. When interior moisture contacts structural framing over long periods of time, decay begins. Many leaning or bulging brick chimney chases are not suffering from soil settlement at all. They are suffering from internal moisture-induced deterioration of the timber framing that is supposed to support the brick. This points to one of the core flaws of the brick veneered chimney chase concept. The system is structurally weak for the loads imposed on it. Brick veneered chimneys are often framed using 2 multiplied 4 studs, as if they were simple architectural features. In reality, a brick veneered chase should be framed much more robustly. A 2 multiplied 6 wall provides greater rigidity, more nailing surface for sheathing, and deeper cavities for diagonal bracing that resists lateral movement. The IRC already requires 2 multiplied 6 framing for 3-story exterior walls because of the increased load and wind requirements. Even though most chimneys are not considered full stories, the stresses on a tall chimney chase can easily equal or exceed those on a full-height wall. A chase extending well above the roofline is exposed on all sides to high suction loads, gust pressures, and thermal cycling. A 2 multiplied 4 chase is rarely strong enough to resist these forces, which is why so many of them lean, twist, or pull away from the house. Once the framing behind the brick begins to fail, the entire assembly becomes unstable, and the brick veneer begins to lean or crack. Homeowners and even some contractors frequently misdiagnose these symptoms as foundation settlement. In reality, the footing may be perfectly sound, while the timber framing behind the brick has rotted away due to years of hidden moisture intrusion. What appears to be a masonry problem is often a structural moisture problem concealed behind the veneer. The brick is only a shell. It is the timber structure behind it that is collapsing. The truth is, brick veneer chimney chases are fundamentally flawed systems. They combine a heavy, rigid exterior cladding with a flexible, moisture-sensitive interior frame. The veneer does not behave like a structural chimney, and the timber structure does not behave like a masonry wall. The two materials expand, contract, bend, and absorb moisture at entirely different rates, and the combination often leads to premature failure. For this reason, brick veneered timber chimneys should be considered high-risk assemblies that require thorough inspection whenever encountered in the field. They should be assessed not only for veneer cracking but for internal structural damage, moisture saturation, missing weep systems, inadequate bracing, and improper load transfer. In many cases, the safest recommendation is replacement or significant structural reinforcement. When viewed through the lens of building science and structural engineering, it becomes clear that the brick veneered timber chimney chase is a system that rarely performs well over time. The best approach is to understand its weaknesses, recognize the signs of internal failure, and advise homeowners accordingly. Even though brick veneer may appear solid and permanent, the structure behind it often tells a very different story. Vinyl siding a timber-framed chimney chase may appear straightforward, but it is actually one of the most technically sensitive exterior cladding tasks in residential construction. A chimney chase rises above the roofline and is exposed on all sides to rain, wind, snow, and fluctuating temperatures. Because of this exposure, every weakness in the siding and flashing system is magnified. Water that might harmlessly escape a standard wall can be driven behind the siding and forced deep into the timber framing. Once moisture gets inside a chase, it becomes trapped, leading to decay and structural weakening. This makes proper siding installation an essential part of chimney chase construction. Everything begins with a correctly framed chimney chase and a properly installed weather-resistive barrier, because vinyl siding is not waterproof. Vinyl only sheds most surface water. It does not stop water from getting behind it. Any moisture that enters the system must run down the weather-resistive barrier and exit at the base. For this to happen, the barrier must be intact, correctly lapped, and free of tears or gaps that could direct water into the wooden chase. Once the barrier is in place, the siding can be installed, but the chimney chase requires a level of detail far beyond what is needed for ordinary walls. One of the most commonly overlooked details is the chimney chase cover. This metal cover must extend fully over the top edges of the siding, including all four corners. Builders frequently make the mistake of sizing the chase cover too small, allowing the vinyl siding corners to remain exposed beneath the edge of the metal. The corners of vinyl siding are extremely vulnerable locations. Wind-driven rain follows these edges upward, and when the chase cover does not project far enough to protect them, water works its way behind the corner trim and into the structure. Once water enters this area, it is very likely to penetrate the weather-resistive barrier and saturate the sheathing and timber framing. Over time, this causes rot and loss of structural integrity in the chimney chase. The roof-to-chimney intersection is another frequent point of failure. Proper step flashing, counterflashing, and kick-out flashing must be installed in the correct sequence. Because a chimney chase interrupts the roof slope, huge volumes of water accumulate and flow against the chase wall during storms. If the flashing is missing, incorrectly lapped, or buried behind siding, water will run behind the weather-resistive barrier and into the chase's framing. Vinyl siding often complicates flashing because some installers place J-channel or siding components in ways that trap water or cover critical flashing layers. If the flashing cannot function as designed, leaks are inevitable. Another vulnerable area is where the vinyl siding and the J-channel meet the home's exterior wall. Many installers neglect to apply an elastomeric sealant at this transition. Without sealing, wind-driven rain can blow directly into the gap where the siding meets the wall. Once water enters that space, it can travel behind the weather-resistive barrier or bypass it entirely if the barrier was perforated during installation. Because the chimney chase is more exposed than the adjacent house wall, this small oversight can result in surprising amounts of water entering the structure. Thermal expansion and contraction present another issue. Vinyl siding expands significantly in hot weather. If the siding is nailed too tightly, it cannot move, and the panels buckle or pull loose. On a chimney chase, even slight movement can break the continuity of the weather-resistive barrier or create gaps that direct water inward. A distorted siding panel can lift enough to expose raw sheathing edges directly to the weather. Another common failure is inadequate reinforcement at the corners of the chase. The chimney chase is a tall, narrow column exposed to wind, pressure, and suction on all sides. The corners are stressed more than any other part of the siding system, If the corner posts or the underlying sheathing are not securely fastened, the siding can flex, lift, or pull open under wind load. Once this happens, water enters freely and migrates behind the siding. The termination area near the chase cover can also be a problem. If the siding is cut too tightly, improperly overlapped, or not integrated with the metal cover, water can be directed inward rather than outward. The space where the siding meets the metal cover should always be protected by proper overhangs, sealed edges, and correct panel alignment, but these details are often overlooked. In reality, vinyl siding a timber frame chimney chase requires considerably more precision than siding a normal wall. The weather-resistive barrier must be perfect, the flashing must be layered correctly, the corners must be fully protected, and the chase cover must extend far enough to shield all siding edges. Because the chimney is exposed on all sides and subjected to extreme weather forces, any weakness becomes an entry point for water. Moisture intrusion is the silent destroyer of timber frame chimney chases, and once it begins, the damage progresses quickly. Done correctly, vinyl siding can protect a chimney chase for many years. Done poorly, it allows water to infiltrate the structure and compromise the entire system. Understanding these vulnerabilities is essential for any inspector, technician, or builder who encounters these structures in the field. Fire stops are among the most critical and most commonly neglected components inside a timber frame chimney chase. Their purpose is straightforward but life-saving. They stop the rapid, hidden spread of fire within concealed vertical spaces. A chimney chase is essentially a tall shaft running from the fireplace connection to the roof termination, and without fire stops, this shaft becomes a direct pathway for flames and hot gases to travel upward with tremendous speed. Many homeowners and even builders assume the chimney itself provides this protection, but it does not. The chimney pipe carries exhaust gases. The surrounding chase is a completely separate cavity that must be intentionally subdivided with fire-stopping materials. Fire stops are required at each floor level, at the ceiling level, and at the attic floor. Their job is to seal the open cavity of the chase so that a fire below cannot immediately rush upward and overwhelm the upper levels of the home. Without proper fire stopping, a small fire in the fireplace enclosure or lower framing can turn into a fully involved attic fire in minutes. This vertical spread is especially dangerous because it can bypass smoke alarms and escape early detection. Properly installed fire stops slow that progression, confining the fire long enough for occupants to escape and firefighters to respond. When factory-built chimneys are installed inside these chases, fire stops take on an even more important function. Factory-built chimneys are tested and listed with strict clearance requirements. These clearances must be maintained not only along the length of the pipe, but also at each floor penetration. The fire stop radiation shield supplied by the chimney manufacturer is designed to keep the combustible framing the correct distance from the hot chimney pipe, while also blocking vertical airflow in the chase. If the fire stop is missing, modified, or improperly installed, the chimney clearance is compromised and the entire safety listing of a system is defeated. This brings us directly to the importance of IRCR 1058 insulation shield, a code requirement that is often misunderstood. In many homes, the attic floor is insulated with loose fill insulation. Without an insulation shield, this insulation can spill over and bury the chimney where it passes through the attic. Chimney pipes get hot, and blown in insulation is often a combustible material. If the chimney system becomes buried in insulation, the required airspace clearance is eliminated, and the insulation can ignite. The insulation shield prevents this by creating a physical barrier around the chimney, maintaining the manufacturer-required clearance and protecting the chimney from being surrounded by insulation. R1058 states that where factory-built chimneys pass through floors, ceilings, or attics, an insulation shield must be installed to keep thermal insulation away from the chimney pipe. This shield must extend from the ceiling level to above the insulation, and it must be securely attached so that insulation cannot fall or migrate into the clearance zone. The shield also functions as a fire stop in these locations, preventing vertical air movement and helping contain smoke and fire.